Now, since I have configured a routing protocol, I can advertise my locally connected networks, right? Or my LAN networks, which I'm learning through the LANing protocol. So again, I have a loopback 1, loopback 2, all right, and this is my tunnel interface. So what I'm going to do, I'm going to run, first I'm going to build this tunnel interface. Second thing is that I am going to advertise this networks under the routing protocol. We'll be using EIGRP because it has fast convergence. That's the second task. The third task is that we are going to implement IPsec here. GRE alone is not secure. GRE
Yes.
with IPsec is secure.
Yes, yes. Actually, that only GRE I did somewhere else with
All
my
right,
one of the
perfect.
customer. Yeah.
Okay. Okay. So let me start with GRE. Only GRE is just your point-to-point connectivity. It doesn't give you any encryption. But now what we are going to learn here is first the GRE, then how you implement your IPsec over that GRE. Again, as I said, the fundamental remains the same. How you configure your phase one, phase two. Now, how you are going to apply it, that is going to be changed. We'll see that how. Okay, let me close this. So if I talk about this particular example only, so it's almost the same lab. Again, I'm going to configure the connectivity between these two loopbacks, but now I have a logical or a virtual tunnel interface. So once that tunnel interface is up, I will be running EIGRP over here. So this tunnel one will be having a neighbor of this tunnel one. So they both will be your EIGRP neighbor. Once that is up, you can very well advertise your networks, how many you want. Now, if I come to what is the advantage, why I want to do GRE, why not side to side? It comes because of the scalability and feasibility challenge. If I have, let's say, 10,000 subnets which I want to advertise, okay, then configuring ACL will be cumbersome, will be hectic. It's not feasible. If I am having 10,000 subnets on each side and I want a full communication between all the subnets with each other, then we can't imagine how much ACLs we need to have on all the sites. And then maintaining ACLs is again very different. And just by looking at ACL, you will not get to know that, okay, who is 2.0 and where he's going, how it is going to be. So it comes with a feasibility challenge. To overcome with that, we have the dynamic routing protocols to leverage because it gives you a lot more capabilities. So in this, what we did last time, the first thing we did in the side to side is your phase one, then your phase two. You define your ACLs, you define your crypto map. What crypto map has your ACL entry, basically your interesting traffic, right? And it also has peer address, or you can call it the destination or the tunnel endpoint. And then you define your transform set. And what you do at last, you just apply it. So that's your side to side. But when you are doing with GRE, what is going to be the same with GRE? Phase one remains the phase one. Phase two becomes phase two. Same. You don't need ACL because ACL tells you interesting traffic. In GRE, whatever is going via tunnel interface is your interesting traffic. Everything which is going via the tunnel will be getting encrypted and encapsulated, which means you don't need ACL here. Now we come to crypto map. Here we use or we give a name it to it as your uh, IPsec profile. Ultimately, same thing, which is binding them all. As I said, we don't need ACL. We are not going to match ACL. Now talking about peer, my destination. When you configure GRE, you are already defining your destination, right? You define your tunnel source and tunnel destination. So now you don't need ACL, you don't need peer. All you need is your transform set. Then you apply it to your tunnel interface. So it's less complex and much more faster. Faster not in terms of convergence, faster in terms of the configuration or the manual efforts which you need to bring that IPsec up. This is what we are going to do in this lab. Let me show you how. Okay, so this is my R1. Again, we will see if connectivity is there. That WAN to WAN connectivity has to be there. I'm pinging R3s of an IP from R1. I'm able to, let's see the routes which I'm having. So I am only aware about the directly connected network and a default route which is going towards your ISP. I don't know the loopback addresses of R3. Same thing here. I don't have any route for R1's loopback, right? Which basically means at this point, if I want to ping loopback address of R3 using my source as a loopback, or even without source, it is not going to ping because there is no route, there is no connectivity. So first thing is that we need to bring the GRE up and then run a routing protocol over it. So how you do it? I will say interface tunnel. I'm on R1. I will say interface tunnel 1. Give any IP address. For example, I want to give a, let's say 200.11.12.1, which is my R1's tunnel interface address, putting that under 211.12.0 subnet. All right. Tunnel source you will be defining. You can give your fast Ethernet 0 by 0, or you can give the IP address as well. Let me give IP here. 10.1 is my IP. Define your tunnel destination, because the physical connectivity between the tunnels is from this is the actual contact. So from R1 perspective, this is my tunnel source and this is my tunnel destination. Packet will be going via this physical link only. Packet cannot go via virtual. So I'm defining my tunnel and source and destination here. Destination would be 192.1.20.3. That's all what I have defined here. Let me show you the tunnel interface config. Right?
Yes.
I will take this and I'll put it here. Okay, this is the config which I'm going to put on R3. So far, I have only configured my tunnel interfaces. If I show you my interfaces, now I can see there is a virtual interface, which is my tunnel one. Same thing on R1. So 211.12.1 is R1 IP. 211.12.2 is R3 IP. Let me put that here as well. So this tunnel interface is my 12.1. This is 12.3 or 2? 2. Okay. I should be able to ping because now these are virtually connected. Let me try to ping 200.11.12.2. I'm pinging from R1 to R3s. And if you see, it will show you as a directly connected. So this network is directly connected to my tunnel address, which means I can run routing protocol. Let's try to run router EIGRP. I'll say no to summary. Network which I want is this network which is connecting to us. Also, I want to advertise my loopbacks. Let's advertise the loopbacks. Okay. Same thing. Okay. Router EIGRP, no to summary. 12.0 is the network which I want to advertise. And as soon as I enable EIGRP on the tunnel interface, my EIGRP neighborship is up. Now I'm going to advertise my loopbacks. Okay. Now I didn't configure ACLs here. Why? Because if I look at this diagram, if R1 wants to or R1 loopback 1 wants to communicate with this guy, what is the path it is going to take? The control plane. It is going to take this path, right?
Yes.
Via the interface. So anything which is going via this tunnel interface will be getting encrypted. Let me show you the routes on R1. So if I want to reach 192.168.2.0 or 17.16.2.0, the exit interface is my tunnel. So whatever is going via tunnel will be getting encrypted or getting secured, right? But as of now, I have not configured IPsec, but let us see if the reachability is there. Let me ping the loopback one address of R3 using the source as my loopback one or my loopback two. Full reachability is there because we are running AIGRP and not doing static mappings with ACLs. Now, the last thing is that now this is a secure communication. R1's loopback can communicate with the loopbacks of R3 in this diagram. The communication is happening fine, but it is clear text. So what we have been talking about, it is clear text, anyone can sniff it and can get the information. Now, what I want to do, I want to implement IPsec on it for this traffic. IPsec is still the IPsec, which still remains the same. Just few configuration step changes. In most of the VPNs, what you will see, phase 1 and phase 2 remains the same, how you configure it. Even in this case, my phase 1 and phase 2 is going to be same. So no change in this. I'm doing for the R1 first. This is the config of previous R3. So when I'm doing it on R1, my neighbor is going to be 20.3, right? This is R3.
Yes.
All right. This is my phase 2. Remains the same. You want to change your algorithms, you can. This remains the same. ACL I don't need. I don't need crypto map. Instead, I need crypto IPsec profile. Crypto IPsec profile, I profile, any name you can give. This is just a name. You can say ABC, whatever you want to do. I'm just giving some relevant name, I profile. I'm going to say set transform set. What is my transform set name? Is T set, right? And lastly, I will apply it on my tunnel interface because that is my exit interface. I will say tunnel protection, IPsec profile, and my profile name. If you are giving ABC here, give ABC here, just a name. So let's go back, review it. This is my phase 1, basically setting my encryption hashing group, the authentication type I'm using, and the lifetime in my phase 1. And pre-shared key, which we were talking about, this is my pre-shared key Cisco. Okay, and this is a neighbor with whom I want to establish this ISACAM phase 1. This is a config. Here I'm saying encrypt the actual data traffic using this encryption algorithm and maintain the integrity using this hashing algorithm. I have configured it separately. Now I will club it. I will say crypto IPsec profile, use the session key from here, and use this transform set. So whatever is now going via this interface tunnel, protect the traffic using this transform set. Basically, you're saying just encapsulate and encrypt the traffic using this transform set. And this transform set needs a session key, right? From here, you will get the session key. Who will be generating the session key? This group 2 will be generating it. And with whom he is going to exchange? With this guy. What is the pre-shared key? Pre-shared key Cisco.
Okay.
Okay. So this is the config. Let me do this config on R1, but I think the old config is still there. Or maybe it's a separate lab. Just give me a check. Okay, it's not there. It's separate lab. So let me paste this config on R1. Then we'll do the config for R3. You will see EIGRP goes down because EIGRP is saying the received packet is not IPsec. Basically, it's saying I'm running IPsec, but the packet which I have received is not an IPsec packet. It's not encrypted. So it's unable to read it, and that's why your EIGRP neighborship goes down. We can fix it. Let's configure R3 for R1. Everything apart from this remains the same. It's just the address which I have changed. Let me put this config on R3. As soon as I put the config, now it is started encrypting the EIGRP hellos and my neighborship came up.
Yes.
So if I see show IP EIGRP neighbor, it is up. If I want to see crypto ISACAMP SA, it should be in ideal state. This is my phase 1. And if I want to see if it is actually encrypting or not, here you can see it is actually encrypting it. If you want to see it, the packet count must be increasing because we are exchanging your EIGRP hellos in every 5 seconds. So this count will be increasing. See, so this is your GRE. If I show you show interface tunnel 1, so the protocol I'm using is my GRE. but now we are securing it with IPsec as well. So this is your GRE plus IPsec.
Yes.
I will show you the config
Yeah.
what we did. That's that's the complete config which we did. Now when we have configured this tunnel, the default mode which this tunnel is used is your tunnel mode. What tunnel mode do? Tunnel mode will add an extra header, okay, to your packet, which will increase the size. Okay, is it fine? Do you have any question on this? Because the next topic, if I start, is going to be difference between tunnel and transport mode, which again is more of theory. Though there is very single command, you just need say change mode to transport, it will do. But it has a big concept behind this. So if you're fine with this, I'll move ahead because I don't
Yes.
want to. Okay,
Yes, yes. Let's move ahead. Sure.
okay then. So default mode, I was talking about the default mode here is your tunnel mode. What happens in tunnel mode? You have two modes for this transform set. Let me type it here. Default one is your tunnel mode, and you also have a transport mode. In tunnel mode, it adds an extra header. Whom the packet, the original packet, what you have, it is going to add an extra header. I will repeat this topic. I'll just what I'll do. I'll just give you a high level overview of tunnel transport mode. We'll be talking about this in detail when we are doing the DM VPN. Otherwise it will be too much of theory, but just to give you an idea of what tunnel mode is going to do, it adds an extra header, and then it basically it's increasing the size of the packet. That's the concern here. Now you will say packet size should not be a concern in today's era, but it is because it is something which is going towards the internet, which has a speed and bandwidth limitation always. So when you're using a tunnel mode, it is X heading extra header. But when you are using a transport mode, it is not going to add an extra header. Instead, it is going to insert a small, you can say, frame of it. So you don't have any extra IPsec header when it goes to transport mode. So if you see at present, R1 and R3 is running your tunnel mode. I will try to show you the packet capture as well next time. So now we are running uh, tunnel mode at this stage. But if I want to change it to the transport mode, I can do that as well. When I change it to transport mode, there is no difference in terms of the traffic or in terms of the data which is flowing across. There will not be any impact on the data user traffic. It's just now you are not adding extra header. So it's a more efficient way and more better way of doing the same thing, because routing will be taken place based on the outside header, which is going to be 192.1.10.1 and 20.2, which will still remain the same. We are talking about the inner headers. So let me show you how you can change this. I will talk about in detail. I'll show you the packet capture as well, how it looks and which is the header it added and it removed. I will show you the headers as well, but for now I think this is fine because otherwise it will be too much of concepts only. So let me change this mode to transport. I'll say mode transport. This side also I will change the mode to transport. Now it says mode transport. It was not showing you tunnel earlier. In few iOS, you will see it will tell you mode tunnel.
Okay.
It was not showing because it doesn't show default things, right? So tunnel was the default mode. Now I have changed it to a transport mode. Now, if I see, if I'm expecting any difference in terms of the ping and other things, it is not there. It remains the same. It's just now you are sending a smaller packets, which will be easy to process and consumes less internet. So in terms of the packet size, if just to give you a reference, for example, if the hello packet size of an encrypted EIGRP hello is 120 bytes. So after changing this mode to transport, you will see that is going to be reduced by at least 16 bytes of it. So 16 bytes look a small number, but if you set the percentage, it is almost 10 to 15% of your complete traffic, which is a huge difference. So that's why you want to move ahead with the transport method. This, if you see the tunnel protocol, I'm not talking about the mode here
Yes.
because it's your tunnel protocol. So tunnel protocol still your GRE, right? So if talk about a packet, how a packet is going to be look like, this is going to be your actual data, which has your source destination MAC. Let's say source MAC. This I'm talking about the actual traffic, the real traffic from loopback to loopback. Now it has a header. Which header it has? It has your GRE header. And from where to where you are running GRE? So I'm running my GRE. Let me define my source first, 192.1.10.1. This is my source. And what is destination of my GRE? I'm doing it from R1 perspective. Destination is 20.3. And which header is this? This is my GRE header. Same thing I have for IPsec. Let me paste it quickly because IPsec is also running on top of it, right?
Yes.
It's using the same source and destination. So it's a kind of your packet, how it is going to look like. So this is your default tunnel mode. Okay. Now, when I'm saying I want to use transport mode, what happens in transport mode? In transport mode, we are basically removing this duplication. Okay. So transport mode in the packet size of the transport mode will be small because we are removing the duplicate IPs. Why we want to do that? Because we are sending from R1 to R3. So it's a duplication. This is going to be the endpoint for your IPsec and endpoint for your GRE as well. So why do we want duplication, right? We want it to be more efficient. Okay. Okay.
Okay.
So I was showing you how the packet looks like when it goes from the tunnel mode. So this is your actual payload, this data. This is the source and destination MAC, the real. And when it gets encapsulated with GRE, because you are running GRE, right?
Yes.
This is going to be GRE, source and destination. On GRE, you are running IPsec. So which brings your duplication. So to avoid that duplication, to make it more efficient, to have a smaller size of the packet, what we are doing, we are changing the mode to transport mode. Now, when it gets changed to transport mode, in the transport mode, what happens? Essentially, it is removing the duplication of your IPs. So this duplication of IP will not be there, which means your packet size will be reduced. How we do is because it just adds IPsec in between the existing headers. So that's what we did. Now this both is type of your transform set, how you are dealing with your transform set. But there is one more efficient way of doing this. As we remember, we configured a GRE tunnel, right?
Yes. Yes.
So instead of doing all this, there's one more way. What you can do, instead of having this encapsulation as a GRE, you can change the encapsulation to IPsec directly. So directly you can configure this tunnel in a mode of IPsec, not the GRE. So what you are seeing now is your GRE encapsulation. A tunnel protocol, what you are using is your GRE. So if I change this to IPsec IPv4, that the duplication of the header will be removed. So what basically it is going to do, transport mode will remove this thing, right? As I told you, this duplication will be removed. But when you change it to IPsec IPv4, right, it removes this header as well. So entire GRE is now removed because you have changed it to directly IPsec. So this will not be there. Let me show you. Now what I want to do, I am going under the interface tunnel mode, IPsec IPv4. I've did it on R1. Let me do it on R3 as well. Okay. Now I change the tunnel mode. Now if I want to show interface tunnel 1, neighborship flagged as expected, it came up as well. The tunnel protocol what I'm going to use now is my IPsec. Earlier it was GRE. Now it's IPsec both sides. That's your GRE VPN. So just a quick recap what we did today. We did site to site, site to multi-site is task for you. Just same thing. You just need to have two entries under the crypto map. Solutions you already have. And what we did is your GRE plus IPsec under your tunnel mode, which is your default, and your transport mode. Lastly, we changed this to IPsec IPv4. So we did all this today. Next task for us is MGRE. Do you know what is MGRE? Have you
Yes,
directed
yes, it is
multi-point GRE, right? Because
multi-point. Yes.
both the tunnels what we have understand is in nature they are point to point. Even you are doing multi-site, but again it's a point to point. R1 to R3 and R1 to R5. So two different virtual tunnels you have. So GRE gives you capability over one interface tunnel. You can communicate with multiple spokes. This GRE is again point to point. Okay, because point to point has your tunnel and destination. So 2 points of that tunnel. But in GRE and in MGRE, you cannot define destination because there will be a multiple destination. So we'll see that in action. What is MGRE? We are going to do this with static NHRP because MGRE alone is of no use unless you deploy NHRP, and then we'll see dynamic NHRP. Let's go in depth. Let's do static NHRP with IPsec and dynamic NHRP with IPsec. You also call it as DMVPN. This is for tomorrow. This is big topic. Don't want to get too much tomorrow as well. If you are able to finish this, then it's also good. Once we are done with that, we'll take a look of what are CA certificate based VPN. So as a CA based VPNs, I will configure one router as a CS server. In real environment, you have a CS server, but here we use your router as a CS server, and we will configure your site-to-site VPN. How you use certificates. Currently, we are using pre-shared key, right? But again, you need to have it on both the sides in a clear text. So more efficient, more better way is going to use your public-private keys. We'll see about that here, and then we'll go to the advanced VPNs, which is IKv2 VPNs. We'll do both site-to-site and GRE, and after that, let's see. Okay, so for tomorrow, we are targeting this. Okay,
Okay.
this was for today. This is your task. I'll send the Eve setup in some time, and then you can practice all this. If you have any question, we'll see. Else, we'll start this tomorrow.
Okay, that's fine.
All right.